Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about the IPC rules as well as the IPC nomenclature, and we have also did the structural formula of the IPC nomenclature. And now based on this thing, now what we are going to do is we are going to perform, or we are going to write the structural formula, the bond line formula as well as the IPC name for the isomers of C7H16. So let us do that. So now here we are going to draw the structural formula, the bond line formula, and we will write the IUPAC name for the isomers of C7H16. That means a hydrocarbon, basically an alkane, which has 7 carbon atoms in its overall molecule and 16 hydrogen atoms in the overall molecule of it. And based on this we have to draw the isomeric structures of it, and we have to write the bond line formula as well as we have to write the IUPAC name of each isomers. So let us start with the first one, because it consists of a molecular formula that is C7H16. So therefore the first molecular formula that they have provided to us is basically C7H16. So therefore the structural formula of that would be, that can be written as in this format, like the 7 hydrocarbons are present in a straight chain and 7 carbon atoms are present in a straight chain, and we could write the hydrogen and fill the hydrogens also. So therefore this is the primary one, so therefore this could be written as CH3. Again this is the primary, can be written as CH3, while the middle one, that is all the carbon atoms that are present between this primary carbon atoms would be basically CH2, 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 basically methylene groups would be there. And now we could easily write the IUPAC name for that. But how can we write the bond line formula? Bond line formula is nothing but a representation of a molecule, might be alkane, alkene or alkyne or any other group like alcohol or organic compound, in such a manner that it should represent in a line, and it should represent it by the lines, and the lines can be zigzag also. So therefore it will be represented in the form of a zigzag lines, and which the point represents or the origin represents the molecule to be called as the primary carbon atom, while the intersection, if we are getting a point and it is intersected by the two lines, then that would be considered as CH2, that is known as methylene. And if we have got 3 lines that are originating from a point, and so that would be basically CH, and if there is 4 lines that have been originating from a particular point, then that would consist of carbon only. So for this thing it would be very much easy to understand that what would be the bond line formula of this structure that we have drawn. It is very much simple, because the carbon atoms are 1, 2, 3, 4, 5, 6, 7 carbon atoms have been present. So this could be written as, this point represents CH3. This is the intersection between the two lines that we could see. So therefore this point would be nothing but the CH2. Again this would be the CH2. So therefore CH3 is what we have got. Again CH2, that is what we have got. Again CH2, that is what we have got here, or we have represented in that manner. Again CH2, and again we will get CH2 over here, and then again CH2. So let us count that how many points that we are getting. We should get at least 7 points. So for that, 1, 2, 3, 4, 5, 6. Only 6 points are being represented in this case. So now it is been 7. So this is the bond line formula of this structure, and this structure is basically known as what? Because this is a straight structure, and we could see that the 7 carbon atoms have been present, and moreover it is an alkane. So therefore the name of this would be heptane or N-heptane. This is what we name the first isomer. So this is the first isomer, and let us see that what would be the next isomer. And we have also represented the structural formula, the bond line formula, and the IUPAC name for this structure. And now let us go for the second isomer that we can draw for C7H16. So the second structural formula for the isomer, and what we will get the second isomer, it would be basically CH3 C. Here we will get a first branch, that is in terms of CH3, it would be CH here, CH2, CH2, and overall the carbon atom should be 7. So therefore here 1 is in branch, so therefore the straight chain would consist of 6 carbon atoms. So therefore 1, 2, 3, 4, 5, and here it is 6. So now if I go with the overall carbon atoms, then I could find that the overall carbon atom is basically 7, and moreover the hydrogen atoms is 16. We could count here also. So now this would be the 16 carbon atom that has been present in the molecule. So now how can we write the bond line formula? The bond line formula, it will be simple. So the first thing that we have to do is we have to draw the zigzag line for the straight chain carbon atom that we have. So in this case what we have is 1, 2, 3, 4, 5, 6 carbon atoms that are present in the straight chain. So we will number that also just for an instance, that 1, 2, 3, 4, 5, 6 carbon atoms are present in a straight chain. So therefore we could write the bond line formula in this format. This would be first, second, third, fourth, fifth, and sixth. 6 carbon atoms that are being present in a straight chain, and moreover we could see that at second carbon atom we could see a methyl group, and methyl group can be represented as a point here. So this point can be joined with this one, so making this to be called as the CH3, because this is a terminal carbon atom, and we could also see that no other kind of line is being joined through this, and this point is basically have a connection with this hydrocarbon or this parent hydrocarbon, making this to be called as a primary alkyl group. And here also it is a primary alkyl group, but here also it is a primary alkyl group. But talking about this one, this is the point where we could see that we could see two lines are being joining, and this is the intersection point, making to be called as CH2. Again, this is a point where the two lines are meeting, so therefore this is CH2. Here also it is CH2. So it is the representation of bond line formula. And so now the bond line formula has been represented for this one. And what would be the IUPAC name for this? So the IUPAC name for this is very much easy, because we have numbered it earlier only, that is 1 to 6. And in this case what we are observing is at the second position, or the second carbon atom, CH3 group is been attached, or the methyl group is been attached. So therefore the name of this would be written in the form of 2-methyl, and the total number of carbons that are present in a straight chain is nothing but 6, and 6 carbon atoms, or we could say for 6 hydrocarbons when in terms of alkane are basically known as hexene. So therefore this would be named as 2-methyl hexane. So these are the two isomers, but yes, there are variable isomers also that we could get, various isomers that we could get. So this is the second one that we have drawn and we have mentioned. So let us go on with the third one. So the third isomer that we'll get is, basically we will get, in this case we have got a branching on the second position, but now what we'll get, we can also make it in the form of the third position, that we will get a branching, or we could get a side chain. So let us draw that also. So therefore the third isomer that would be, it could be written as in this format. So 6 carbon atoms are in a straight chain. And here we see earlier the isomer was present on the second carbon atom, and now it will be present on the third carbon atom if we move from left to right. And if we have given the number that is from 1, 2, 3, 4, 5 and 6. So now at the third carbon atom the methyl group would be present and just fulfill all the hydrogen atoms that we can do. So therefore this would be CH3. This is the methylene group that will be here, so therefore CH2. Again here it will be CH2, and here it will be CH, while here it would be CH2. So now this is the one which is obeying the molecular formula to be called as C7H16. But the structure of this would be is different than compared to that of the earlier two, and making this to be an isomer of the earlier two. And talking about the bond line formula, the bond line formula would be very much easy to represent in this case. So as we could see that the 6 hydrocarbons, or the 6 carbon atoms are arranged in a straight, continuous and long chain. So we could write that in a zigzag form, in the form of, this is the first carbon atom, that is CH3, second, third, fourth, fifth, and this is sixth. So we could join this thing 1, 2, 3, 4 in this format. 1, 2, 3, 4, 5, 6. 6 carbon atoms are being present here in the representation of bond length formula, and I could see that at third position the CH3 or methyl group is been present. So if this is for the first, this is the second, and this is the third, and I could see that at third position basically methyl group is been present, that is can be denoted by this point. So there would be a bond that would be attached, as here also it is been attached. So now this is the bond formula of the third isomer. So now what would be the IUPAC name of this structure? It is very simple to understand because the methyl group that has been attached at the third position. So now it would be very easy to understand that what would be the IUPAC name of this thing. So we could write the IUPAC name as 3-methyl. That represents the methyl group is been attached on the third position of the hydrocarbon that has been present in straight chain, and the total number of carbon atom that has been present in a straight chain is 6. So therefore that could be written as hexane. Simple to understand. So now let us do with the next isomer that we could draw, or in this case suppose if I shift this CH3 to the fourth one, so will that be an isomer? Let us see. If this CH3 is suppose on the fourth position, so what we have did earlier that in second position the methyl group was there, and now at the third isomer, at third position methyl isomer is there. So the fourth one would be at fourth position. So that is true or not? So if we see that if CH3 group is present on the fourth position, then what would be the IUPAC numbering? So the numbering will start from that position or from that end where we could get the substituent to be having a less number. So therefore the numbering will start from here, that is 1, 2, and this would be 3. So that is the reason that if you go from left to right or right to left, you have got the same, you will get the same IUPAC number as well as IUPAC name as well as the same structural formula. So therefore that wouldn't be the IUPAC isomer, that won't be the isomer. So therefore we have to choose another chain that would be different from that of the other three, and moreover if you could say that the IUPAC name should also be the different compared to that of the other three that we have drawn. And so let us choose the new isomer or the next isomer that we could draw, that is the fourth one. And talking about the fourth one will have the structure like the CH3 would be present here, while here a group like CH3 here also, but in the last two, that is the isomer number 2 and isomer number 3, what we have did is we have made 6 carbon atom to be in a straight chain, and now what we are going to draw 5 carbon atoms in a straight chain. For that we will get in this format, that is 1, 2, 3, 4, 5 carbon atoms are in a straight chain, and this would be the 6th carbon atom. So where would be the 7th carbon atom? The 7th carbon atom would be, suppose it is attached over here. So making, if I'll fulfill the valencies of the carbon atom, so this is the structure that we have got, and for this we could write the bond line formula also. It is very much simple, but the first thing is we have to give the number, so that numbering is also very essential so that we don't get confusing any moment. So this would be, from where do the numbering will start? That is the main thing. So for that we should know the IUPAC rules of nomenclature, so that I could start the number from here also, or I could start the number from here. So suppose if I start the number from here, that is 1, 2, 3, this would have got the third position, fourth position or the fourth locant, fourth position of the locant, and this would be the fifth one. So what if I have started the number from here, that is 1, 2, at second position, that is at the second carbon atom I am getting a substituent, and at the third carbon atom I am getting the substituent. So therefore this is the correct method to write the number from left to right, where I get the substituent very much near from a end. So therefore this is the first, second, third, fourth and fifth. And now I could write the bond line formula very easily, because I could see that the 5 carbon atoms are in a straight chain. So for that we could represent in a bond line formula in this manner, that is 1 for this carbon, that is this point representing this carbon, this is for second, third, fourth, and this is for fifth. So because the bond line formula is usually when it comes to more than two hydrocarbons, we represent in a zigzag format. So therefore this is also where we could write in a zigzag format. That is 1, 2, 3, 4, 5. 5 carbon atoms are present in a straight chain, and moreover we could see that at second position and third position there is methyl group. So this is the second one. So here it is a methyl group that has been present, and on the third also there is a methyl group that has been present. So I could write it here as in this manner. So I could join this thing. So now this is the bond line formula of the fourth isomer that we have drawn. So but what would be the IUPAC name of this one? So let us prefer the straight chain, and in this preferring the straight chain, what we have got to know that at second position and third position methyl groups are being present, and both the substances are being methyl. So the thing is, the substance is present at second and third, and since the both are being methyl groups, so therefore we could write it as 2,3, that is dimethyl. And the total number of carbon that is present in a continuous long chain or the parent hydrocarbon is basically 5. So 5 when it comes to alkane, which consists of 5 carbon atoms, so that is nothing known as pentane. So therefore we could write it as pentane. Simple. So this is the fourth isomer that we have drawn, and let us see that what is the next isomer. And we are going in a very good direction, because till now we have calculated the 4 isomers, but let us we have mentioned the 4 isomers, and let us see that what would be the 5th isomer that we could draw. So for that we could take the reference of this one only, and as we could see that one substance has been attached on the second carbon atom, and the next, that is CH3, the second CH3 has been attached on the third carbon atom. So we could make the other CH3, that is this group, to be attached on the fourth carbon atom. Even that is possible, but the molecular formula would be the same, but the thing is the structural formula would be different. So even we could try that also. So let us draw that as to be the isomer of the C7H16. So the 5th isomer can be written as, so by referring the earlier one that we have got, that is 5 carbon atoms that would be in a straight chain, and on the second carbon atom I have made a methyl group to be attached, and on the fourth carbon also if I have made a methyl group to be attached. And let us name it. It would be first, second, third, fourth and 5th. So now fulfilling the hydrogen atoms that is been required. So therefore this is the primary one, so therefore it would be CH3. Again this is the primary carbon atom, so again this would be CH3 here also. So basically here there is 4 primary carbon atoms, and talking about the methylene group, so here it is CH2, and this is methyl group that is been present. So now bond line will be very much easy to understand, because the 5 carbon atoms that have been present in the longest chain, so therefore we could write in this format also 1, 2, 3, 4, 5. Done. And at second position and fourth position CH3 group is been attached, so therefore I could write the CH3 or the methyl group in the second position to be like this one, and on this is the first, second, this is the third, and on fourth position I could see the methyl group. So again this I could name it also, but since it is the representation of the structure that is given above, so it is not necessary to name it, not necessary to number the carbon atoms, because it is just representing the above one. And now could give the name of the isomer. So in this position what I could see that at second and at the fourth position I could see the methyl groups, and this is both are methyl groups, so I could write the IUPAC name of the structure to be called as 2,4, and since methyl group is repeating 2 times, so therefore I could write as 2,4 dimethyl. And the total number of carbon that is present in a long chain form, or the parent hydrocarbon that I am talking about, is basically pentane, because 5 carbon atoms are present in a straight chain. So therefore making it to be called as a parent name having pentane. So even this is very simple to understand. So this is the thing that we have got to know. And what are the other things that we are that we would see in this thing is, this is the 5th isomer, but as you would see that these 2 substituents that are being attached on the second one, so there could be a possibility that these 2 are being attached on the third carbon atom. So now the next isomer that could be written as in this format, where all the 5 carbon atoms that are being present in a straight chain, so therefore I would write in this format, that is 1, 2, 3, 4, 5. And both the substitutes, that is both the carbon atoms that are being left, so that they could be attached on the third carbon atom like this one. So this could be written, so before that let us number it, so therefore this will be the first, second, third, fourth, fifth, and moreover it is a straight chain. I can't choose this to be a straight and a longest chain, and so therefore we could fulfill the hydrogen atoms. So therefore let us, will be the primary one. So as we have said that the primary one are usually the one which consists of 3 hydrogen atoms, and this is also 3 hydrogen atoms, while this is the methyl group, methylene group. So again this is the methyl group, and this is the one which doesn't contains a which doesn't need hydrogen to be fulfill the vacant, because it is already been fulfilled by the vacancies of the other carbon atoms. And now we could give the bond line formula of this thing. So because the 5 carbon atoms that are being present in a straight chain, so we could write this in this format like 1, 2, 3, 4, 5. 5 carbon atoms are being represented. But as I could see that at third position I could see a methyl group, and again on the third position I see a methyl group. So therefore there are 2 methyl groups that are being attached. So therefore on the third group, on the third carbon atom, so therefore I could write this to be called as the first methyl, and this to be called as the second methyl. So it is very much simple to represent the bond line formula. And moreover we could see that bond line formula is not much very tedious, because we don't have to represent every time CH3, just we have to make points and we have to just join them, and that's it, and it will make a good representation of a particular alkane. And even that is very much easy, and it looks good also. Means the thing is not a very tedious work to write, and even that is a kind of representation that most of we are using in our daily life, especially in laboratories. So basically molecular formula is basically the one which is basically the molecular formula is the one which is usually used in the chemical industry. But yes, even these representations are also being used, and they have a significance of it. So now let us come back again to the IUPAC name, and let us see that what would be the IUPAC name of this above one that we have. So as I could see that the CH3 or the methyl molecules, methyl groups are being attached on the third carbon atom of the parent carbon atom called to be pentane. So since there are 2 methyl groups that are attached to the third position itself, so therefore we could write it as 3,3 dimethyl, and the total number of carbon that are present in a straight chain or the longest chain carbon atom according to the IUPAC in this structure is called to be pentane. So therefore this is the one we have. So we could draw another structure also, that is when if these 2 are being attached on the third position or the third carbon atom, we could also make it to be in the second position. So now for that let us write the structure, and for which we will get, suppose if I am representing the 7th one, and all the 5 carbon atoms that are being present in a straight chain or in the longest form. So this is the one that I have drawn, and on second carbon I am choosing it to be having methyl groups, that is CH3, and just fulfill the valencies of a carbon atom. So therefore this will be again CH3 called to be the primary carbon atom, again this would be CH2 because it is a secondary carbon atom, again CH2 because it is a secondary carbon atom. So now the bond line would be very much easier to understand because we have did it earlier also, but numbering also very important. So we'll number it as first, second, third, fourth, fifth. So the bond line formula would be 1, 2, 3, 4, 5. 5 carbon atoms are being represented in a zigzag format, basically the bond line formula. And in second position, what I could see methyl groups are being present. So therefore I would attach over the second position here, and again on the second position. So this is the bond line formula of this structure that we have. But what will be the IUPAC name of this one? This one would be just like the previous one, but only the difference would be that the positions were at the third, that is the position of the substrate were on the third as well as again on the third. So now in this case it is second and again second, so we could write it as in this format, that is 2,2, that is dimethyl, and the overall carbon atom that is present in straight chain is basically 5, so called to be as when it comes to an hydrocarbon, especially alkane, called to be as pentane. So this is the 7th one that we have drawn, but yes, there are also many possibilities, so we'll try that also. So let us come back again to the 8th isomer that we could draw. So that is, so the 8th isomer can be written as, if suppose if 5 carbon atoms are being attached in a straight chain, and on the third one, if I have observed to be having a ethyl group, so now even this is the one which is showing an isomer, but I can't make this ethyl group to be attached on the second one, on the second carbon atom. Suppose if I number this thing, that is 1, 2, 3, 4, 5. Suppose if this is the one that if I have attached on the second carbon atom, then this would be the first, second, third, and in third position I could see a methyl group. So this is the one that we have mentioned earlier also, and what we have did an isomer for that. So that is very much easy. So that would be very much similar to that of the third one that we have did earlier. So now what we are going to do is we are going to fulfill the hydrogen atoms in this case. So therefore we could fulfill the hydrogen atoms, and now it is very much easy to draw the bond line formula. So since 5 carbon atoms are present in a straight chain, so we could write in this format that 1, 2, 3, 4, 5. 5 carbon atoms are being present in a straight chain, and we could see that at third carbon atom, and we have shown an ethyl group that is being attached. So therefore, if this is the first, second, third, and at third position basically the ethyl group is being attached, so I could write it in this format. So this end represents CH3 while this end represents CH2. So this is very much easy to represent the bond line formula. But yes, what would be the IUPAC name? That is the main thing that we are going to do for that. And the IUPAC name of this would be very much easy, because at the third position, because the ethyl group is present, so we could write as 3 ethyl. And the total number of carbon that is present in a straight chain and in a longest form, basically the parent hydrocarbon in this case is called to be, yes, it is called to be pentane. So this are the 8 isomers that we have drawn, but yes, one is also left, and the last one is, let us do that also. So for the 9th one that we have, we could make the isomer to be called in this manner, that is 1, 2, 3, 4. 4 carbon atoms are being attached in a straight chain, and in the second we could get 2 branching, making to be called as the 6 carbon atoms that are being present here, and the third would be, or the last would be basically here. So now this is an isomer that has basically 6 carbon atoms, and let us fulfill the hydrogen atoms and we'll number it later on. So this is the one that has the isomer which has basically 3 substituents. And how? Because for that we have to choose the longest chain, and in this case what would be the longest chain? 1, 2, 3, 4, or else 1, 2, 3, 4, or else 1, 2, 3, 4. In any way you choose, you will get the longest chain, but we would prefer from that end where we could get the most number of branching. So that's the reason I can't number it here to be called as the first one, because if I call it to be the first and this would be the second, then here I could see only one substituent, and the third carbon will get the 2 substituents. So for that I will take the number from this end, so as this one would be the first, this one would be the second, third and fourth, and on second carbon atom I could see that there are more substituents, that is 2 substituents that are being attached on the second carbon atom and 1 substituent that has been attached on the third carbon atom. So here I have followed the rule of the IUPAC nomenclature, and I have mentioned this to be called as the numbering of the carbon atoms. So now we could now since we have mentioned the numbers also, as well as we have also mentioned the substituent groups, so therefore it would be very much easy to draw the bond line formula. So in this case, because the 4 carbon atoms that have been attached in a straight line or in a longest form, continuous form, so therefore I could write it as 1, 2, 3, 4. 4 carbon atoms are in a straight chain, and on second I could see a methyl group is in presence. So therefore if this is the first one and this is the second one, so a methyl group is been attached on the second carbon atom. Again, a methyl group is attached on the second carbon atom. And on third also, there is a methyl group that has been attached on the third carbon atom. So we could call it as in this manner also. So this is the bond line formula. Actually, I have represented in a dot form just as to make you sure that the one which has a terminal end are basically the CHA. So that's the reason for that I have made a dot here, so as to represent just for an instant. And yes, but what would be the IUPAC name of this thing? As I could see that this is the longest chain that I'm observing, and on second and on third I could get the substituents, and second contains two substituent, that is two methyl groups, and the third contains one. So therefore the name of this would be 2,2, 3, because this is the position where the substituents are being attached. And moreover and more specifically, we could see that at second position and at third position of the carbon atom, methyl groups are the only substituents that are being attached. Means there is no other different substituents like ethyl or propyl. All the substituents that are being present here is only of one type, that is of methyl. That is the reason what we have did. We have made the position to be that is submerged configuration, that we have made all the substituent numbers, that is second and the third, to merge in itself, and so as to be called as 2, 2, 3. And I could see that 3 methyls are being attached. So therefore tri-methyl. And the total number of carbon in straight chain is basically 4, and 4 carbon it represents when it comes to an hydrocarbon, and especially for alkane it is called to be butane. So very simple to understand this one. So this were all the isomers that we have did for the isomer that, or the molecular formula that was been provided to us for, that was C7H16, and of which we have to draw the structural formula, we have to draw the bond line formula, and yes, we have to give the IUPAC name of this isomers also. So this is what we have done. So a very much easy thing, but the only main thing that we should be concerned of, that we should know that how to draw the isomers. And the isomers are nothing but, as you know, that they will have the same molecular formula but different structural formula. So this is a structural formula that is to be make in concern, and because of which we could draw different kind of structural formula that should obey the molecular formula. So this is how we have represented this one. So it is very easy for you, and I hope you will try this kind of isomers for yourself. And thank you friends for watching this video. I hope you have liked this video and you have understood this concept very clearly, and share this video with friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.